Before we talk about the pH scale, we will explain how to calculate the concentration of hydrogen in relation to pH. To do this, you need to have a basic understanding of logarithms. We will work with two formulas. Formula 1. pH equals negative log base 10 to the concentration of hydrogen. H plus represents the concentration of hydrogen. Formula 2. Concentration of hydrogen equals 10 to the power negative pH. There is an important relationship to note between the concentration of hydrogen and pH. The higher the concentration of hydrogen, the more acidic the substance becomes. The lower the concentration of hydrogen, the more basic the substance becomes.
pH 1, the strongest type of acid. Concentration of hydrogen in this acid is 10 to the power of negative 1, or 0.1 moles per dm cubed. When this acid is tested with pH paper, a paper that determines the pH of a substance, it turns red, which indicated the strongest type of acid, or pH 1. An example of an acid of pH 1 is battery acid, and is often found in car batteries. Extremely dangerous as strong acids are very corrosive. pH 2, also very strong acid. Concentration of hydrogen in this acid is 10 to the power negative 2, or 0.01 moles per dm cubed. When this acid is tested with pH paper, it turns into a slightly lighter shade of red, which is indicative of a pH 2 acid. An example of an acid of pH 2 is sulfuric acid, which is used in phosphate fertilizers. Not as corrosive as a pH 1 acid, but still dangerous to handle. pH 3. This type of acid leans towards the weaker side. Concentration of hydrogen in this acid is 10 to the power of negative 3, or 0.001 moles per dm cubed. When this acid is tested with pH paper, it turns into a light shade of orange, which indicates pH 3. An example of an acid of pH 3 is lemon juice and vinegar. These acids are a good source of taste making in food as they have a nice sour taste. pH 4. This is an even weaker type of acid. Concentration of hydrogen in this acid is 10 to the power negative 4, or 0.0001 moles per dm cubed. When this acid is tested with pH paper, it turns orange-yellow, which indicates pH 4. An example of an acid of pH 4 is tomato juice, and it is also edible. pH 5. As the pH increases, the acid gets even weaker as the concentration of hydrogen decreases. The concentration of hydrogen in pH 5 acid is 10 to the power negative 5, or 0.00001 moles per dm cubed. When this is tested with pH paper, it turns into yellow-green. An example of this kind of acid is found in bananas and black coffee, and is very, very weak. pH 6. The weakest acid on the pH scale. Concentration of hydrogen in this acid is 10 to the power negative 6, or 0.00001 moles per dm cubed. When this acid is tested with pH paper, it turns green, which indicates pH 6, as seen in the image above. An example of an acid of pH 6 is milk, something that cats love to drink. pH 7. This is neutral, which is neither acid or base. An example of this is water, as it is an example of a classic neutralization reaction. The concentration of hydrogen in water is 10 to the power negative 7, or 0.0000001 moles per dm cubed. When this is tested using pH paper, it turns sea green, which indicates neutral. pH 8. Now it moves on towards the side of bases. pH 8 is the weakest base. Concentration of hydrogen in this base is 10 to the power of negative 8, or 0.0000001 moles per dm cubed. When this base is tested with pH paper, it turns a shade of bluish green, which indicates pH 8. pH 8 bases include seawater or eggs. pH 9. This is slightly stronger than pH 8, obviously. The concentration of hydrogen in this base is 10 to the power negative 9, or 0.0000001 moles per dm cubed. When it is tested in pH paper, it turns into a light shade of blue, which is indicative of pH 9. Examples of pH 9 is baking soda, which is a common ingredient in baking. pH 10. The substance slowly starts increases in basicity as we go up in pH scale. Concentration of hydrogen in pH 10 is 10 to the power of negative 10, 0.000000001 moles per dm cubed. When the substance of pH 10 are tested with pH paper, it turns the pH paper into a shade of sea blue, as seen in the image above. Examples of pH 10 include milk of magnesia and mild detergents, which are both not edible things. pH 11. As said earlier, basicity keeps increasing up the pH scale. The concentration of hydrogen in pH 11 is 10 to the power of negative 11, or 0.00000000001 moles per dm cubed. When substances of pH 11 are tested with their pH paper, its dark blue color is seen above. Examples of pH 11 include ammonia solution, which is a very common substance used in the chemistry lab and also inedible. pH 12. Substances of pH 12 are on the strong side of the bases. Concentration of hydrogen in this acid is 10 to the power of negative 12, or 0.00000000001 moles per dm cubed. When a substance of pH 12 is tested with a pH paper, it turns into a shade of bluish purple. An example of a substance of pH 12 is soapy water. pH 13. This is the second strongest type of base. Concentration of hydrogen in this base is 10 to the power of negative 13, or 0.00000000001 moles per dm cubed. When a substance of pH 13 is tested with a pH paper, it turns purple. An example of a substance of pH 13 is bleach or oven cleaner. Strong bases are often used for cleaning purposes. pH 14. This is the strongest base. The concentration of hydrogen is the least compared to all of the pH scale. It is 10 to the power of negative 14, or 0.0000000000001 moles per dm cubed. When a substance of pH 14 is tested with pH paper, it turns into a shade of dark purple. An example of a substance of pH 14 is liquid drain cleaner. As said earlier, very strong bases are used for cleaning purposes. They cannot be eaten.